Okay, we're going to talk about a couple different angles today. Let's draw one out here. We're going to actually do work a few word problems. Let me go through some stuff, and then I've got some examples that I actually scanned from the book. We'll take a look at it, see how it goes. All right, pretend this is the ground right here. Right, this horizontal line right here is the ground, and let's pretend. Let's do this in a different color. That looks brick color, doesn't it? Does that look brick? That looks brick. So I want to make it brick looking. So watch. Let's pretend this is a building right there. All right, and I can actually fill it in too. Look at that. See how pretty that is? All right, so there's a brick building right here. Here's the ground, and let's just pretend that there's a certain spot on the ground that we want to look at. So we're at the top of this building. We're looking straight down at this spot on the ground. Yes. Okay, we'll scooch over then. So watch this. What we're going to do is we're going to take, we're here at the top of the building. Just scooch the desk over. You could just go one way or the other. You could see, right? Couldn't you? I don't want you sitting in the back row. So look what we're doing. This is very important. Let's pay attention. Let's not talk. So what we're looking at is this. You're up here. You're looking down at a spot down here on the ground. There's several different angles that are formed. Now, we have to make a little bit of an assumption here. We're assuming that this building is perpendicular to the ground. All right. Hopefully, most buildings are perpendicular to the ground. Maybe Leaning Tower of Pisa is not perpendicular, but for the most part, most buildings, okay, if they're built right, are perpendicular to the ground that they're on. Would you agree with that? So if it's perpendicular, what kind of an angle does it make right here? It's a right angle. Okay, so that would be a right angle right here. All right. What we're doing, let's pretend we could either be here on the ground looking up, or we could be up on top of the building looking down. Doesn't matter. We're going to actually talk about both of them. Let's talk about being on the ground looking up in this direction. It's formed an angle right here. Do you see this angle? Okay, this angle has a special name, and we call this the angle of elevation. Because elevation means goes up, right? You're in an elevator, right? Elevators, well, they go down too, I guess. But when we think of elevator, when we think of elevate, right? To elevate, we go up, correct? So here's the horizontal. The ground is considered to be horizontal. Again, we're making assumptions here. We're assuming we're not on the side of a mountain or something like that, okay? We're assuming that it's flat and that this is horizontal. So from the horizontal to that line of sight, remember, we're looking up this way. That diagonal line right there is our line of sight. This angle right here is considered our angle of elevation. All right? So that's what we consider that. Now let's go up to the top of the building. So now we're on the top of the building. We're looking down to this spot on the ground. A lot of people would think that this angle up here would be the other angle that we're going to talk about. Well, we are going to talk about another angle. Instead of elevation, we're going to talk about another angle called the angle of depression. Now, it's not depression because it's a really sad angle or anything like that. All right, it's depression because if elevation means goes up, what does depress mean? Do what? If you depress on something, it goes down, right? That's where they get the word depression. You know how you're all sad and you're lonely and all that kind of stuff because you're feeling down, right? You're down in the dumps, right? That kind of thing. That's, I guess, where they get the word depression because you're down. All right, so what is our angle, though? We got to be careful with this. Let's draw another line. Remember what I said was here. This is from the horizontal up. Do you see it? So what do you think the angle of if I could talk right, the angle of depression is going to be? Is from the, remember, this is from horizontal up. So this has to be from
up to down.
No, from, look, from horizontal, key word, from the horizontal up to the line of sight. So this is going to go from the horizontal, okay, I'm trying to give you big hints here. From the horizontal up, this is going to be from the horizontal down. Exactly right. But we got to draw a horizontal. I don't have a horizontal drawn, do I?
No.
Maybe that's why you're getting a little confused. So now this is just kind of like a, actually let's do this a different color, yellow. All right, this is right here, just kind of like an imaginary horizontal. You follow me? So you just kind of have to think, okay, that would be horizontal, and the angle of depression is from the horizontal where? Down. So this angle would be from here to here. That would be the angle of depression right there. Okay, it's depressed because we're going down. You got it? So angle of depression. You're looking straight out, horizontal. And then if you look down, the angle that's formed with the horizontal in that line of sight, that right there is your angle of depression. So this is your angle of elevation. This is your angle of depression. Remember I said this yellow line was horizontal, didn't I? What was that blue line? It was also horizontal. So that must mean what's true about those two lines right there? They're parallel to each other. If they're both horizontal, they're parallel to each other. With that said, tell me something about the angle of elevation and the angle of depression. They're equal to each other. Give me a reason. We learned that a little while back. Very good. It's alternate interior angles. Remember that? Parallel lines cut by transversal. The alternate interior angles are equal to each other. All right, so if I have two parallel lines, the alternate interiors are angled. That means what? The angle of elevation equals what? The angle of depression. That's right. So if I was up here on top of this building and I said, okay, my angle of depression was, I don't know, 17 degrees, then what does that tell you about this angle down here at the bottom? It's going to be the same exact thing, isn't it? It's 17 degrees. A lot of people think the angle of depression is this one that's in between here and here. It's not. The angle of depression, angle of elevation always starts from the horizontal. Elevation goes up, depression goes what? Down. Everybody see that? It's not too hard to see, is it? But you got to remember it. Again, as many times as I say this today, I bet you anything, some people are going to say, if the problem says, well, the angle of depression is 17 degrees, I have a feeling that some people are going to put 17 degrees for this angle right here. But that's not correct, is it? It's from the horizontal down to the line of sight. From the horizontal down to the line of sight. Everybody see that? Okay. What they're going to do is they're going to give you some word problems. I don't want you to be scared off by them because they're actually the same style of problem. Almost every one of these is about the same style of problem. It's really not much different. You just have to read it and be able to see what the author is saying of this problem and then figure out how to redraw it on your paper. Basically, we have a right triangle. And you have angles in here, and you got lengths of sides. That's what they're going to give you. They'll probably give you an angle on one of the sides, and you got to find one of the other sides. And that's basically all there is to it. All right. Let's do an example where we do this. If it's sideways, I'm not sure what you mean. Well, because you've got a horizontal and you've got a vertical. Whatever is from the horizontal to the line of sight is either the angle of depression or angle of elevation. See, this is from the horizontal to the line of sight, which is going down, is the angle of depression. It doesn't really matter if you go down or up, right? I mean, because look, if I start from the horizontal here and go up to that line, that's 17 degrees. If I start from the horizontal up top and go down to that same line, it's still 17 degrees, isn't it? All right. So most of our triangles are going to look just like this, though. We're going to have a horizontal. It's not going to be slanted. All right. These problems won't be slanted where everything's off at some crazy angle. Nope, this will always be horizontal, and this will be vertical, and then you just have to figure out either what the angle is or what the lengths of the sides are and all that good stuff. All right, and we're going to do that by our trig functions. For instance, what if we wanted to find out how tall this building was? Now, it might be difficult to jump up on top of the building, have a big tape measure, right, and throw it down to the ground and measure how tall the building is. But they do make devices that measures the angle. Okay, they're fairly simple devices. I made one in physics class not the other day, but it's been a bunch of years since I taught physics. But they do make these devices. They call them all kinds of things, but they make a device that measures the angle from the horizontal. So it's really not that hard to do to find out what that angle is. Now, we don't carry one of those around with us every day, but who knows? With the phones and the smartphones and GPS and stuff, maybe you could even find an app for it, right? That on a phone that actually figures out what what that angle is. So let's say we're standing on the ground, right? And we look up here, we see the top of the building, and we see it's 17 degrees. Might as well just use that angle. I just made that angle up for whatever reason. And we're like, there's really no way I can sit here and actually measure the height of that building, but I could pretty easily just walk it off, right? From here all the way to the building. I could take a piece of string or rope or a tape measure or whatever, or just kind of take some steps, right? You ever do that? Like you measure out like a yard, like one big long step is a yard. Did you know that? Depending on how big of a step. Here. Look, this thing right here is a meter stick. So a yard is just a little short. It's about 3 inches shorter than this. A yard is about like this. So watch, if I was to measure something out, if I started right here, I would go just kind of take a long step. That's 1 yard. You ever do that when you're a kid playing football, right? Out on the field or something, you want to figure out how long it is, right? You always do that, don't you? Or playing baseball, you want to figure out where the pitcher's mound is and all that kind of stuff. Yeah, you just mark it off. So you could pretty easy, tell you the truth, figure out that distance. I don't know. Let's just make up a number. Let's say it's 200 feet. I don't know. I'm just making something up off the top of my head. Okay. Let's say that's 200 feet. We want to find out how tall that building is. Call it h for height. So where is the height? It's from here straight down to here. Wouldn't you agree? All right. So I got a lot of junk all written around here, but what are we going to do to figure out the height of that building? Any ideas? Are we going to use Pythagorean theorem? Are we going to use what? I mean, what do you think? Yeah, sine, cosine, or tangent. Exactly right. Our trig functions. Okay, that's how I want you to refer to them. All right, we're going to use one of our trig functions. So Isaiah, you're thinking about it. I see it. That's good. What did you come up with a good trig function for this? Okay, cosine. How'd you get cosine? Adjacent over. Problem is, what? Don't know the hypotenuse. Okay, it's a good guess because we do have adjacent. Why tangent, Joe? Opposite over adjacent. That's right. Because I don't know hypotenuse, do I? And I'm not trying to find the hypotenuse, so I'm not really going to use that. But I can find this. It's h, but it's not hypotenuse. This is the height. Okay. So this is opposite over adjacent. Opposite over adjacent is the tangent. Right? We're remembering that stuff, aren't we? So we've got the tangent of what? What angle am I working with here? 17 degrees. Good. 17 degrees equals the opposite over the adjacent. Which one's the opposite again? H over the adjacent, which is 200. All right. And now we can do a little simple math and then solve for h. How do I get h by itself? Good. Multiply it by 200 and multiply this by 200. I was watching some videos last night of some people teaching this stuff, and I do that every once in a while because I like to see how other people explain it. And I was watching this one guy, and he always said tan all the time. I don't even think he said the word tangent. He said tan, 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 tan all the time. And then some people are doing this. They put 200, and then they put an X, and then he put like tangent of whatever. I don't think it's necessary to have that X right there. I just put the 200 in front of it. That means 200 times the tangent of 17. The tangent of 17 is just some old number, right? I can put that in my calculator. So let's do this. Put 200, and then on my calculator, I don't even have to hit times. All I got to hit is what? Tangent of 17. All right? Plug that in. Boom. There we go. 61. We'll just round it to the nearest degree. What is that? That's 61 what? That's actually, it's not 61 degrees. I'm sorry. I said degree, but it's not. It's 61 what? It's feet, right, because this is measured in feet. So the height is, we didn't find an angle, did we? We found how tall this building is. So that's 61 feet. All right? So that's how we can find how tall that building is. 200 feet this way, and then 61 feet this way, 17-degree angle. It's kind of a neat thing. If you do it on a regular calculator, when I say regular calculator, you know what I mean, the TI-30XA or whatever it's called, hit 17 tangent first. You can do it a couple ways, but do it like this. Hit 17, then tangent. You'll get some decimal number, won't you? Okay, and then you just times it by 200. Multiply by 200, and you'll get that same exact number right there, won't you? Yeah. You get that same number. We just rounded it to the nearest foot, so it's 61 feet. What do you think? That's not so bad, is it? All right. Now, I took a few minutes to, actually all of last period. I didn't do this for my other class. I saved this for you guys. All right. Not that you'll really care that much, but let's do this. This is right from the book, right? So it's not that big of a deal. Let me make it bigger for you. Do that. Do this. Now, this was kind of near the crease in the book, so it kind of went a little fuzzy, but I think we have enough there to figure out what's going on. Okay, so here we go. We got this nice castle. Somebody's standing right here. Now look, can you see like a dotted line right here on the ground? Now they start the height at where his eye is. All right, what's a 5.5? What's 5.5? Do you think? How tall he is exactly, or at least where he's looking from, where his eyeball is, right? So from here to here is 5.5. So really, what's that?
It's a girl.
It's a girl? Oh, Leah. Sorry. What did I say? He all the time? Oh, I'm sorry about that. She. It's Leah. She. So she is 5.5 feet tall, and she's looking up to the top of the castle. All right, so she's looking up here. Now, it would be pretty impossible. It'd be pretty tough anyway to climb all the way up to the top of the castle, throw down a some kind of measuring device, either a ruler or something like that, or even a rope, and measure it. It'd be pretty tough to do that, and you probably wouldn't want to do that. People at the amusement park probably don't want you climbing up to the top of this tower. All right.
Don't they, like, use their hair or something?
Well, Rapunzel probably could use her hair, yeah, but we don't have Rapunzel with us. Okay, so or what's that kids movie out now? Tangled. Is her name Rapunzel, or what's her name? Is it Rapunzel? Okay. The name of the movie's Tangled, but it's about Rapunzel. I haven't seen it. Have you seen it? I guess, Jesse. You saw it. Okay. Was it good? Okay. Is it Disney or is it Pixar, or do you know? Is it Disney? Okay. All right. So watch from the top. Hey. So what we want to do is we want to find out. Actually, they told us how tall it was. I wish they would have done it the other way, but that's okay. Let's just do it like this. They told us how tall it was. I don't know. The people at the amusement park measured it out. We got to figure out how far it is from here to the bottom of that castle, right? From that top right there. So really, I think it's pretty simple. What are we going to do? Let's do this. Sometimes we want to redraw the triangle so you don't have all the junk in there. You know what I mean? All the picture and all that, because that kind of just gets in the way. All right, so let's put the numbers in. What do we have? We got an angle, don't we? So we have an angle. That's adjacent to this angle, and this is what? 190. And so now what we can do is we can figure out that distance right there. But the problem is this. Is this really 190? Let's think just a second.
Not because you gotta take away the 5.
That's right, because look, the 190 goes from B all the way down to the bottom. Do you see that? But that's not, that little part right there is really not part of our triangle, is it? So really, this is not 190. That was a little bit of a trick. Okay, what is it?
184.
That's it. It's 184.5. Now, where in the world did I get that number? Yeah, subtract her height, right? So, because look, from here to here is how tall she is. So we take away that 5.5 from the 190. Now we got the bottom of the triangle. Everybody see that? So it's a little bit of a trick. It wasn't that much of a trick, was it? All right, it was kind of easy to figure out. So really, this is not 190 now. It's 184.5. Why? Because we took away that little height, that 5.5, from the whole entire 190, and then we're good to go to find this. Do you agree? All right, so let's do this real quick. Brett, you said it. What was it? Use tangent again, right? Opposite over adjacent. But this is a little different, though. Watch. That's right. The tangent of 38 equals opposite, which is 184.5, divided by the what? Adjacent, which is x. Now, this math isn't quite as easy as the math that we did a little earlier, but it's really not that bad. I'll show you a little trick after we do this. X is on the bottom. We don't want x on the bottom, so we multiply it by x. We did this before. Okay, it's not the first time. So we multiply this by x, and we multiply this by x right there. So that x cancels out with that. Now, how do we get rid of that tangent of 38? Divide it, right, because tangent of 38 is actually a number. If you don't believe me, watch. Put tangent of 38, tangent of 38. That's just a plain old number, 0.78, blah, blah, blah. But it's a number, isn't it? Yeah. How do we get rid of a number that's being multiplied by a variable? We divide, don't we? So we divide by the tangent of 38. So what's it going to look like? It's going to be 184.5, what? Divided by, yeah, but we'll just write in the tangent of 38. We're not going to write in the decimal right here. Okay, it's a lot easier just to do it all in one shot in your calculator than to write down that big old decimal. All right, well, let's see what we get here. So we got 184.5 divided by the tangent of 38. Tangent of 38, and hit equals, and there it is, 236. Is that what you said, Joe?
Yes.
All right, so equals 236. We'll just round it to that. And is this in feet, I guess?
Yeah.
Okay, so 236 feet. So that's how far Leah is away from the bottom of that top point right there, okay? From the castle, we'll say. So from here to here is 236 feet. Make sense? It's not too hard, is it? All right, let's do another one. Time to get out of here. Chapel, I never remember. Chapel schedule, 40. So I got about 8 minutes left. All right, let's do another one. I've got a few here. We won't be able to do all these that I have. What do you want to do? Emergency, lifeguard, amusement park, marathon, telephone pole. Which one? Amusement park? Okay, there's two of them.
Alright, never mind.
Well, you picked it. Well, there's part A and B. I guess there's two of them. This is right from the book. Okay. Well, it's just like a field trip in here. All right, here we go. India, Enrique, and Trina. All right, they went to the amusement park, and they're in Japan. All right, they're in Japan. All right. So anyway, who cares what their names are? Let's just. I guess their moms do, and they probably do. But all right, they went on a Ferris wheel that was 100 meters in diameter. So we know what. I mean, you know enough about circles, right? What a diameter is. It goes right through the circle. Do you see that? And oh, they're two different rides. Okay, and on a 80-meter cliff dropping slide. So that's just the cliff dropping slide right here is. Okay, so they want two rides. Here's the Ferris wheel. Here's the cliff dropping slide ride. Is it slide or ride? It looks like a log flume, so it might be a slide. Okay.
It says ride right there.
It does say ride, but then it says how long is the slide? Whatever.
Put a shrine.
Let's look at this one. Watch. When they're at the top part of the Ferris wheel, when they're right here, it says how far are they away from India? Not the country India, but their little friend India right here. Okay? So it's not the country, it's her friend. Okay? So basically, what's this distance right here? All right, that's what we're looking for. Let's make this, what do you want to call it? D for distance. Is that all right? So we want to find that distance right there. Well, what else do we know?
So the
It says, go ahead.
The 57 degrees is the same as the left side, right?
Yeah, exactly. Watch this. This 57 degrees is taken from her. She's looking at the horizontal, and she's holding her little measuring device thing, right? Her angle measuring device down like this, and it tells her, oh, that's 57 degrees down to my friend down at the bottom. But that's not really part of our triangle, is it? But if this is the angle of depression, where's the angle of elevation?
Down where India is.
Where India is, right. So that would be what? 57 degrees. Everybody see that? What else do we know? We don't know any numbers here as far as the lengths of the sides or anything. Well, it does tell you the diameter of the what? Of the Ferris wheel, right? So that means from here all the way down to here is how much? It's 100, okay? Yeah, they're fudging just a little bit, okay? But we'll say the bottom of the Ferris, because the Ferris wheel usually comes pretty close to touching the ground, you know? So we'll say it's 100, though, all right? So that length right there is 100, and we're trying to find the hypotenuse, okay, D. Now, again, we got all that junk around it, don't we? It would be kind of nice if we drew it without all that stuff around it. Let's go blue. So let's just draw a nice little triangle like this, and then like that. Just looks a little cleaner, doesn't it?
Yeah.
All right, so that's 57 degrees. We're trying to find D, and we're given that to be 100, and it's a right triangle. Now we can use our trig. All right, aren't you glad we learned the trig? So let's see, which trig function do you want to use here? What is 100 to this 57? It's what? Is it adjacent, opposite? Well, what is the 100? It's opposite. It's opposite the 57. What is the D? Okay, so now opposite hypotenuse. Which one goes with that? You sure about that? It's the sine. It's SOH. So, ka, toa. Adjacent over hypotenuse is the cosine. Opposite over hypotenuse is the sine. All right? So let's use the sine. The sine of what? 57 degrees equals the opposite over the adjacent. So, I'm sorry, hypotenuse. You got me saying adjacent now. So it's 100 over what? D. What's the math? Now watch. Multiply by D, divide by sine of 57. If you have a situation like this, watch. Basically, all you're doing is just switching places with the D and the sine of 57, aren't you? All right, so I could kind of do this in my head. Do you think? Write it down. So D, right, I replaced these two, right? I substituted, basically. All right, so D is equal to what? 100 over what? Sine of 57. See what I did? Put the D on top, put the sine of 57 on the bottom. I just switched places with those two things. Because that's how it works out. It's how it worked out up here. Right? Isn't it? Because look, I had an x down the bottom, I had a tangent of 38 on the top. What did we end up doing? Just taking the x and putting it here and the tangent of 38 and put it down here, right? Not skipping steps. We're doing the steps in our head, but I want you to there are quicker ways to do things. I'm not really skipping a step at all. I set up my formula, right, with a sign, and then I got d by itself. That's not skipping any steps at all. All right, it's perfectly fine. And now we stick this into a calculator and see what we get. We got 100 over the sine of 57. Sine of 57. And then that's 119. So 119, whatever it is. How many times do you have to ask me that? I thought we've gone through that. We went through that before. So it's 100, watch, on a regular calculator, on a small scientific calculator. It's 100 divided by, then you got to hit 57, then sine. I've said this over and over and over again. On those calculators, you hit the number first, then you hit the function. All right? It's the only difference between that one and the one that I'm using up here on the board. So you hit 100 divided by, hit 57 sine, but then you have to hit equals. All right? Do it, and you'll get that same exact number. You got to practice it. All right? Depending on what kind of calculator you have and use, you put in things a little differently. Make sense? All right, let's do one more, okay? And we'll see, and then I'll give you a worksheet to do tonight. Let's see, place. All right, let's go emergency. Okay. They gave you some little helpful hint here, but here we go. You can read the whole thing, but what do we have? They give you the angle of depression, don't they? Well, that's going to be the same thing as the elevation. This is pretty much the same style of problem we've been doing, okay? It's just another one to look at. All right, so what trig function are we going to use? I'm not going to do this whole thing just because of time. What trig function are we going to use with this situation? Tangent again, opposite over adjacent, right? Everybody see that? So the tangent of 42 equals 18 over x. Got to solve for x, right? And we've done that a couple times already. We won't do that anymore. Let's just look at another one. See if they're any different than this. Place lifeguarding. Let's see what that one's about. We did this one in fourth period. But I didn't have the picture for him. I just kind of read it off to him. But look at this. Lifeguard's watching a beach at a line of sight 6 feet above the ground. Why is she 6 feet above the ground? Because she's sitting on this big chair, right? All right, so, but she's sitting. She's lifeguard, 6 feet high, right? She's looking down. Here's the swimmer. It's 8 degrees. Now, what kind of triangle are we going to draw?
Cute.
And a cute one.
No,
Same right.
it's a right triangle.
Same.
Okay, look. We want to make, oops.
Oh.
Right triangle.
See, we want to make a right triangle out of it, right? Everybody see that? All right, so let's draw it down here. We've got this down here like this, we got this like that, and we've got that. All right, so watch. This is angle of depression now, isn't it? So this angle is what? That's 8 degrees. What's it say? She's 6 feet high, right? So where's the 6 feet? That's not even part of our triangle. That right there, isn't it? That's the 6 feet. So there's the 6. What else do we know?
We know that the angle is 8 degrees.
That's it, right? What are we trying to find? How far away from the tower is the swimmer? Right? So how far away? It would be this horizontal line. We'll call that x. And you can do it. What trig function are we going to use on this? Tangent again. Opposite over adjacent. Let me give you a worksheet before you go.